Before we move on to talk about how does the stress being applied on a specimen affect the strain experienced by the specimen, let's talk about a few specific terms that we use to describe the mechanical properties of a material. Okay, we usually say a material is strong. What does it mean by strong? If we say a material is stiff, what does it mean by stiff? When we say material is brittle, what does it mean? Okay, so there are a few terms that we usually use to describe the material properties of matter. So I'm going to introduce it here. You learn about the specifics in later videos, but I'm just going to put down terms here so that you won't get confused when I mention these terms later. Okay, so what does it mean when we say an object is brittle or ductile or malleable? Okay, these three terms are usually, I think you've experienced it firsthand. You have read about these terms in your chemistry when you learn about the properties of solid. You learn about ductile and being malleable. Okay, so here I'm going to, what do you call it, sort of quantify or let you know how we say, what do we mean when something is brittle? What do we mean when we say something is ductile? How do we measure it? Okay, we're going to put it in more specific terms here. Okay, so we say an object is brittle. If the object is brittle, it means that the object fractures with little or no plastic deformation. Fractures means by it breaks. Okay, so the object will break with little or no plastic deformation. Plastic deformation, you learn it in later video when you enter these sections over here. Plastic deformation means permanent deformation. Okay, so it means by this object here will break before it experiences any kind of permanent deformation. So if you stretch, before it even reaches permanent deformation, it will break. Okay, so it means that it can easily break when you stretch it or if you compress it. Okay, so a brittle, later we'll talk about what kind of objects are brittle. Okay, so now the next term that we learned about is ductile. Okay, if we say an object is ductile, it means that the object fractures after a great amount of plastic deformation under tensile stress. Again, tensile is we are pulling the specimen. So if we say an object is ductile, it means that the object will only break after a great amount of permanent deformation or plastic deformation. It means that when you stretch a specimen, the object will undergo some amount of permanent deformation, only it will break. Okay, means when you stretch, you let go, or it's a permanent stretch already. Okay, but you continue to stretch, or some add-on permanent deformation again, continue to stretch, only you will break. Okay, previously when we talk about brittle, it won't even get into permanent deformation, then you break already. Okay, but for ductile, you can stretch, there's some permanent deformation, quite a great amount of permanent deformation, only you fracture. Okay, that's the idea of ductile object. Okay, and lastly, malleable. Malleable is sort of the opposite side of ductile. Okay, it's not that it's little deformation, but it's for compressive stress. Okay, if we say an object is malleable, it means that the object fractures after a great amount of plastic deformation under compressive stress. So if we say an object is malleable, you press on it, you continue to compress even more, compress even more, permanent deformation. After a great amount of compress, after a great change of its length already, only it will break. Okay, so the object can be pressed and it can change shape very severely after being pressed until at a certain point only it will break. Okay, so ductile is when we talk about stretch, malleable is when we talk about press. Okay, but brittle is you won't even get to permanent deformation, you break already. Okay, so some kind of examples that we usually have for brittle object is like glass. Okay, glass, you don't see your glass being stretched. You can get a longer glass usually, right? When you stretch or you press on it with certain amount of force, you break even before it starts to experience any kind of severe stretch. Okay, so glass we call it as brittle. Okay, but things like gold, like copper, you can see that gold and copper, they can be made into long wire threads, right? Okay, filaments or threads. Copper, they can be made into threads easily because when you pull, it will undergo a long stretch before it breaks. Okay, if you pull, you can make it even thinner, you can make it even thinner, you can make it even thinner. That's why it forms into a wire shape. That's why it won't break so easily when you're stretching it. That's why we say that these materials here are ductile. Okay, whereas lead is a malleable kind of material because if you press on it hard, it will compress even more until a very strong level of compressed already, only it starts to break. So you call this kind of object as being, this kind of material as being a malleable material. Okay, so these are a few terms, and this is how we actually, what it actually means. Okay, so if we talk about a brittleness, if it has a high level of brittleness, it is very brittle. If it has a low level of brittleness, it is not very brittle. Okay, if it's ductility, it has a high ductility, then you say that the object is very ductile. If it has a low ductility, then the material is not very ductile. Okay, I think you get the idea. Great malleability means by you are able to it's very greatly malleable. But if it's the low malleability, then it means that you press a bit, then you fracture already. Okay, so ductile and malleable are sort of the opposite of brittle. Okay, an object which is brittle cannot be ductile and malleable. An object that is ductile and malleable can never be brittle. They are sort of the opposite end of things. Okay, so these are the three different terms. In the next video, we'll talk about things like strong, things like stiff, things like tough.